Hello, everyone. I guess you can hear my voice. I can unmute you all. Okay, do you all hear my voice?
Yeah.
Yeah.
Yes.
Yeah.
That's very good. I mute you whenever you want to ask a question or say something. I guess you can unmute yourself. Or you can just raise your hand. Okay. Okay, hi Star, hi Dennis. Okay, on Blackboard, there's a file in document. I think it's Algebra 9. .pdf. You can look at that file. We are going to solve those questions. Okay. Okay, we are going to continue with group theory. Can anyone please send me the notes from the week before the class? I asked the professor over the mail and she told me no. Okay, we are going to continue group theory. And today we are mostly focused on the order of elements. Okay. Okay, so whenever you want to say something, you can unmute yourself and say something. I think you can unmute yourself. I'm not 100% sure. Can one of you just try? Can you unmute yourself and say something? Okay.
Hello.
Nice. Yeah, good. Okay. Okay, so let's start. The first question is find the order of all elements in Z7 star. This is a star. Okay, so I would explain the question and then I give you a few minutes. And I give you a few minutes to solve the question and then I would solve it for you, okay? So let me just explain the question. As you know, Z7 means all the numbers from 0 to 7. 0, 1, 2, 3, 4, 5, 7. There's a kind of notational notes, something here to remind you. If it just mentions Z7 as a group, if it mentions Z7, the operator of this group is sum, even if we don't write that. So if someone just writes Z7, we really mean the operation is addition. So the operation between 1 and 2 would be just a sum. Okay, but when we use this extra star here, it kind of changes everything. When we use this star, it means we should only look at the elements which are co-prime with respect to 7. Okay, so what is the 7 star? What are those elements? Oh, sorry, here we don't have 7 anymore. It starts from 0, 5, 6. Okay, so when I use this star here, I should only look at the elements which are co-prime with respect to 7. So it means their greatest common divisor with respect to 7 is 1. For example, 0 is not co-prime with respect to 7, so 0 is not going to be here. 1 is co-prime, 2, 3, 4, 5, and 6. All of them are in Z7. So as you can see, Z7 itself has 7 elements. And Z7 star, it has 6 elements. Okay, so these are two different groups. And another important thing here is that here, as I mentioned in the first case, in Z7, the operation is addition. So for example, 1 plus 2 is 3. This is the group. In you're asking everyone what is your email, or you're asking me? Or you're asking the previous person who wrote something? Oh, okay. Let me tell you something. When you want to ask something from a specific person, you can just send your message to that specific person. So just send to, there's everyone. You can choose like the name of whoever you want. Okay. Okay, and in the second case, in Z7 star, the operation is multiplication. So here, when we have 1 and 2, the operation is really multiplication, which is 2. So remember, whenever there is no star, the operation is addition. Whenever there is a star here, the operation is multiplication. That's one difference. The other difference is that whenever there's a star here, we only consider the elements which are co-prime with respect to this number, for example, in this case, 7. Okay, let's look at another example very fast to make sure we really understand this thing. So for example, let's look at, say, Z6. So Z6 includes 0, 1, 2, 3, 4, and 5. And as I said, even if we don't write it explicitly, the operation is addition. If we write Z6 star, this group includes all the number which are co-prime with respect to 6. 0 is not one of them, 1 is one of them, 2 is not co-prime with respect to 6, 3 is not co-prime with respect to 6, 4 is not co-prime with respect to 6, only 5 is co-prime with respect to 6. And the operation is multiplication. Okay, so these, as you can see, in the first case, we have 6 elements. And in the second case, we only have 2 elements. Okay, so that's how it's defined. Anyway, so we are interested in Z7 star. So is there any question about the definition of these things? Okay, if it's clear, we can continue with Z7 star. Okay, I can erase everything actually. Okay, so let's look at Z7 star. 1, 2, 3, 4, 5, and 6. And the question is that find the order of all of them. So order of elements. Okay, you can think about this for a few minutes. It's not very hard. Just compute them, and then you can start to tell me your answers. Okay, so let me explain. So first of all, again, because here we have star, it's the 7 star. When I'm asking about the order of elements, I mean with respect to multiplication. So order of an element would be the number of times which we should multiply that element by itself until we get to 1 identity, which here identity of this element, this group is 1. So the order of 1 is just 1 because we don't need to multiply it by itself to get to 1. It is just 1. So order of 1 is equal to 1. So that's always the thing. Order of identity is always equal to 1, right? Now we want to find the order of 2. Okay. Okay. Because 2 is not identity, of course, its order is not 1. The only element which its order is 1 is the identity. So we should look at 2 squared. It's 4. It's not 1. 2 cubed is 8. But here everything is mod 7 because we're in the 7 star, and 8 is the same as 1 because, well, maybe I should write it, because 8 is the same as 8 minus 7. Remember, 7 is like 0 when we are in mod 7. So we're allowed to add or subtract 7, and 8 minus 7 is 1. So in this group, actually, 8 is equal to 1. Okay, so the order of 2 is 3 because 3 is the first number, is the first time 2 to the power 3 is the first time that it becomes 1. So its order is 3. Isn't there a way to find out what the possible order values can be? Like in this situation, the only options are 1, 3, or 5, right? Okay, so there, in general, for every group, there isn't any way to do that. Actually, there are kind of theorems which show there is no general way to find that. The thing which we know is that the order of any elements, I can write it here. If our group is finite, like in this case, our group is finite, it has 1, 2, 3, 4, 5, 6 elements. When the group is finite, order of every element, or any element actually, any element, it divides the number of the elements of the group. It divides the number of elements of the group. So here, our group has 6 elements, right? So order of anything should divide 6. What are the numbers? What are the natural numbers which they divide 6? There's 1, there's 2, there's 3, and there's 6. So these are all the possible things we can have. Okay, now let's look at 3. Okay, 3, 1 is 3. 3 squared is 9. 9 mod 7 is 2. It's not 1. 3 cubed is 27. What is 27 mod 7? Okay, we can think about it as -1. So it's the same as 27 minus 28. Because 28 is 4 times 7, which is -1. Okay, so 3 to the power 4 is 3 Any question? No. Okay. 3 cubed times 3. 3 cubed is -1 times 3 is -3. And -3 mod 7 is 4. So let me say something. We already kind of know what is the order of 3. The order of 3 is not 1, right? Because 3 to the 1 is 3. The order of 3 is not 2, because 3 squared is 2, and it's not 1. It's not 3, because 3 cubed is -1, and it's not 1. So what is the order of 3? Can you tell me? Does anyone know the answer? You can unmute yourself and just say it.
Is it 6?
Yes, you're right. Because, yep, say it. Okay, that's it. Don't you want to add anything?
Oh no, I just said yay because I got it right.
Okay. So so the order of 3 is 6 because it's not 1, it's not 2, and it's not 3. And as I just told you, because of this theorem, the order of any element here should be one of these 4 numbers. And if it's not 1, 2, and 3, it has to be 6. So we don't need to continue our computation. Now we can just say the answer is 6. I will erase this question mark. I will write 6. So this is, it follows from this important theorem that the order of any element should divide the number of the elements of the group. So here our group has 6 elements. So order of any element should divide 6. Okay. So let's consider 4. So I would erase these because we don't have much space actually. Okay, let's look at 4. So 4 to the 1 is 4. 4 squared is 16, which mod 7 is the same as 16 minus 2 times 7, which is 14. And that's 2. Okay, 2 is not 1. What about 4 cubed? 4 cubed is 4 times 4 squared. But 4 squared is 2. You can see here, 4 squared equals 2. And this is 8. And mod 7, 8 is the same as 8 minus 7, which is 1. So the order is 3. So here the order is 1, here the order is 3, here the order is also 3. Okay, let's look at 5. 5 to the 1 is 5. 5 squared is 25. But what is 25 mod 7? It's 25 minus, well, 21. 3 times 7 is 21, which is the same as 4, which is equal to 4 actually. So it's equal to 4. I would erase again these things. So 5 cubed is 20. And 20 mod 7 is, again, 20 mod 7 is the same as 20 minus 21. Because 21 is 3 times 7. And this is -1. And it's not 1. So the order is not 1, as you can see here. The order is not 2, as you can see, because 5 squared is not 1. And the order is not 3. So the order has to be 6. The order is equal to 6. We don't need to continue the computation. So as you can see, this theorem helps us a lot with finding out what is the order. Okay, let's look at the last example. 6 to the 1 is 6. 6 squared is 36. But mod 7, 36 is the same as 7 times 5. We are allowed to add or subtract multiplications of 7, which is 35. And 36 minus 35 is 1. So the order of 7 is 2. As you can see, 6 squared equals 1. So the order is 2. So now we have the order of all the elements, and as you can see, 1, 3, 6, 3, 6, 2. These are just these 4 numbers. Okay, any question? Okay, so let me erase these. We can look at the second question. Find the order of 2 in Z23 star. So find the order of 2 in this group, Z23 star. Okay, you can think about it for a few minutes. Yeah, that is correct, Victoria. So if the order of something is 1, say there is some number x such that the order of x is 1, it means x to the 1 equals 1. But what is 1 in this group? Remember, here when we have star, it means the operation is multiplication. So 1 is the identity. And x to the 1 is just x, so x equals 1. And in this group, as I said, when the operation is multiplication, 1 is identity. So yes, only order of identity element is 1. That's correct for every group. So if order of something is 1 in any group, that something is the identity element of that group. Okay, let's find the order of 2 here. Does anyone know the answer? You can just unmute yourself and tell me what is the final answer. Okay, so Z20 star, how many elements does this group have? What is we show it with this notation. It's not the absolute value of the group. It just means the number of elements this group has. What is it? Yeah, 22. That is correct. So the reason is that Z20 star, Z23 star has all the numbers. Okay, so Z23 is 0, 1, 2, 3, up to 22. And there are 23 numbers here, right? Because there are 22 numbers from 1 to 22, and then there is 0. So in total, there are 23 numbers there. Now, in this group, in the second group, Z23 star, we should only look at the elements which are co-prime with respect to 23. It means their like greatest common divisor with 23 is 1. 0 is not co-prime with respect to any number, because the greatest common divisor of 0 and anything is 0, and of course it's not 1. So 0 does not come to this group. This group doesn't have 0. But every other number here, like 1, 2, 3, every number, the GCD of these numbers, maybe I should write GCD. The GCD of these numbers with 23, all of them, all these numbers, they all are equal to 1. 22, 23 is equal to 1. Why is that true? Because 23 is prime. Because 23 is prime. Whenever a number is prime, it's co-prime with respect to all numbers which are less than that number. So here 23 is prime, so it's co-prime with respect to every number which is less than 23, every natural number. The only case which is not correct is 0. So all the other elements, they all are here in this group. So we have the numbers from 1 to 22, and so in total there are 22 elements. Is it clear? Is there any question here? Okay. Now we want to find the order of 2, but as you remember, I just said the order of any elements divides. So like this, I mean it divides the total number of elements in that group, which is 22. So what are the numbers which divide 22? 1, 2, 11, 22. These are the natural numbers which divide 22. There is nothing else. So the order of 2 is one of these numbers. So we should just try these 4 numbers to see which one of them is the answer. Actually, we don't need to try all 4 of them. We only need to try the first 3, because if it's not, the order is not the first 3 numbers, it's not any of them, it has to be the last one, which is 22. Okay, so let me erase everything. Okay, so is the order 1? Well, no, because 2 to the 1 is 2, and it's not 1. And as also you remember, I said only the order of identity is 1. Is the order 2? 2 squared is 4. 4 is not 1. So the order is not 1, it's not 2. Is it 11? We should only check that. We should see if 11, 2 to the 11, to the mod 23. We should see if it's 1 or not. Okay. So what is 2 to the 11? I can break it into smaller pieces, right? So for example, I can write it as 2 to the 5 times 2 to the 5 times 2, right? This is 5 plus 5 plus 1 is 11. So I can break 11 as 5 plus 5 plus 1, right? 2 to the 5 is 32. So this is 32 times 32 times 2. But what is the remainder of 32 mod 23? Well, 32 I write it here. 32, or maybe it's better to write it somewhere else. I would write it here. So 32 mod 23 is 32 minus 23, right? And this is 9. So 32 mod 23 is 9. The second 32 is also 9. And then there's another 2. And this is the same as 81 times 2. But what is 81 mod 23? So 81 modulo 23. What is it? Okay, so I can, for example, subtract, I guess, 3 times 23. I guess that would work, because that's 69. Right? And I guess that's 12. Okay, so 81 is just 12, and 12 times 2 is 24, and 24 mod 23 is just 24 minus 23, which is 1. And that's what we wanted, right? So 2 to the 11 equals 1. That means order of 2 is 11. Okay, is there any question? Okay, so if there isn't any question, let me erase this page. Also, this lecture is being recorded, so I would upload it on Blackboard, so you can look at these again later if you want. Okay, now we want to look at the group. We want to look at the group S4, which means permutations of 4 elements. And we want to find the order of a few elements here. So first, find the order of this element, 1, 2, 3. Okay, think about that for a few seconds or a minute. Okay, so again, let's see. 1, 2, 3 is not identity, right? So the order is not 1. What about 2? Let's see, 1, 2, 3 squared means 1, 2, 3 times 1, 2, 3. Okay, in order to see what is the result of this product, we should see where is the destination of every element. Let's look at 1 first. 1, we should start from right. 1 goes to 2. Then 2 goes to 3. Therefore, 1 goes to 3. Okay, so now I erase these two. What is the destination of 3? 3 goes to the next element, but the next element is 1. And 1 itself goes to 2. So 3 goes to 2. So that's the destination of 3. Now let me erase these two. Where does 2 go? 2 goes to 3. 3 goes to next element, which is 1. So 2 goes to 1. So 2 goes to 1. When 2 goes to the first element, we can close this thing. And as you can see, this is not identity. What about 1, 2, 3 cubed? Well, that is equal to 1, 2, 3 squared times 1, 2, 3. But 1, 2, 3 squared itself is 1, 3, 2. And then we have extra 1, 2, 3. Okay. Again, in order to see what is the result of this multiplication, I should see what is the destination of every number. So 1. 1 goes to 2. 2. 2 goes to the next number, which here is 1. So 1 goes to 1. So 1 doesn't move at all, so I don't need to write 1. So I just erase 1. What about 2? 2 goes to 3. 3 goes to 2. So 2 goes to 2. So I don't need to write 2 because it doesn't move again. So I just erased. What about 3? Okay, 3 goes to 1. But 1 goes to 3. So 3 goes to 3. So again, I don't need to write 3 anymore. So it doesn't move anything. Therefore, this is the identity element. So the order of 1, 2, 3 is 3. Okay? Any question? Okay, now we want to do the same thing with another element of S4. This is 2, 4, 1. So just repeat exactly the same computation with 2, 4, and 1. Okay, so again, we do the same thing. The order of 2, 4, 1 is not 1 because this element is not identity. Remember, in the group of permutations, identity is the element which doesn't move any number, right? It is the element which doesn't move anything. So what about 2, 4, 1 squared? Okay, so in order to compute that, we should write it like this. Okay, so where does 1 go? I should start from 1. 1 goes to 2, 2 goes to 4. So 1 goes to 4. Okay, where does 4 go? 4 goes to 1, 1 goes to 2. So 4 goes to 2. Okay, where does 2 go? 2 goes to 4, 4 goes to 1, so 2 goes to 1. But whenever we get something, a repeated element, we have 1 here, we have 1 here, and we also have 1 here. We erase this one and we close the parentheses. And this is not identity. So the order is not 2. What about 2, 4, 1 cubed? This is 2, 4, 1 squared times 2, 4, 1. But 2, 4, 1 squared is 1, 4, 2. 2, 4, 1 squared, as we computed here, is 1, 4, 2. And then we have 2, 4, 1. Okay. What is the result? Where 1 goes to 2, 2 goes to 1. So 1 goes to 1. So I don't need to write 1. What about 2? 2 goes to 4. 4 goes to 2. So 2 goes to 2. So 2 doesn't move either. I don't need to write that. What about 4? 4 goes to 1. 1 goes to 4. So 4 goes to 4. I don't need to write that either. So it doesn't change anything. So that's identity. So order of 2, 4, 1 is 3. Okay, now that's a general thing. The order of a cycle with length n is n. What do I mean by that? So 2, 4, 1. It's a cycle, right? It's a cycle. The order is the number of elements. It has 3 elements, 1, 2, 3. So the order is 3. So if instead of S4, we were in, say, S10, and we had a cycle like this, 2, 7, 5, 3, 10, 1, 4. And they were asking us what is the order of this thing. We don't need to do these computations anymore. We say this is a cycle, and it has 1, 2, 3, 4, 5, 6, 7 elements. The order is 7. That's always correct. We don't need to do this computation anymore. That's how it works for cycles. Any question? Okay, so let's look at the last part of this question. Now we want to see what is the order of multiplication of these two. So we want to see what is the order of 1, 2, 3 times 2, 4, 1. What is the order of this thing? Okay, think about that for a few seconds. GCD of both? No, I mean, no, not GCD. I mean multiply these two things together. It means multiplication in this group. So let me write it again. So 1, 2, 3, 1, 2, 3 is an element there. 4, 2, 1 is another element there. There are two elements of 2, 4, 1. There are two elements of this group. If you do multiplication, you would end up with another element in S4. And I'm asking what is the order of that element. Does it make sense? No, I mean, first you should do, no, it's, that's not true now. That's only correct if, so you're right, you are remembering a correct theorem. If we have different things and if we multiply them, the order would be the greatest common divisor of the order of each one of them. If there was another extra condition, they were supposed to be disjoint, like they were supposed to not have any element in common. So here we have 1 here, we have 1 here, we have 2 here, we have 2 here. Yeah, if it was like 1, 2, 3, if we were in like S10 and it was 7, 5, 6, that would have been correct. Yeah, it's correct for disjoint cycles, yes. Okay. So one thing we can do, we can just do the multiplication first to see what is the result and then compute the order of the result. So again, what is the image? What is the destination of 1? 1 first goes to 2. 2 goes to 1. So 1 doesn't move. So I don't need to write 1 at all. Oh, I think I made a mistake. Sorry. Let's check that again. Where does 1 go? 1 goes to 2, 2 goes to 3. So 1 goes to 3. We should always go to the element which is on the right-hand side. On the right-hand side of this 1 here, because there's nothing on the right-hand side, it's 2. And here 2 goes to 3. So 1 goes to 3. What is the image of 3? What is the destination of 3? 3 doesn't go anywhere here. Here, 3 goes to 1. So 3 goes to 1. We can close the first cycle. Okay, what is left? Let's start with that. 2 is left. Okay, 2 first goes to 4. 4 doesn't go anywhere. So 2 goes to 4. What about 4? 4 goes to 1. 1 goes to 2. So 4 goes to 2. So I can close this one too. Now, here we have multiplication of 2 cycles. Here we also have multiplication of 2 cycles. But I'm telling you that this one is better. We like this one. We don't like this one. Why? What is the reason that I'm interested in this one, but not this one? They are disjoint. You are right. So as you can see here, how we have 1 and 3. Here we have 2 and 4. So 2 and 4 do not appear here. 1 and 3, they do not appear here. But here we have common elements. 1 is here, 1 is here, 2 is here, 2 is here. They are not disjoint. So we always like these disjoint cycles. So the order of that is equal to order of 1, 3, 2, 4. Okay. What is order of 1, 3? It's 2, because as I told you, order of any element, any cycle is the number of elements of that cycle. It has 2 elements, so its order is 2. The order of this one is also 2. And because they are disjoint, we can use the theorem that you mentioned. The order is going to be GCD of these numbers, 2 and 2. And their GCD is, of course, 2. So the order of this multiplication is 2. So finally, the order is 2. Any question? Okay, I guess that's it for today. Is the quality good? Do you hear me well, or is the is there any delay or anything? Let me unmute you. Okay, it's good. Okay, okay. Thank you. Be safe and study well. Also, I will be online on Zoom on my MLC and my office hours. So if you have any question, you can just ask me through Zoom on those specific times. I never got my test before break. Anyway, I can see it. Oh yeah, I'm not sure. I guess Jean had your test. Am I right? The other TA had mistakenly, I think he had your test. If that's the case, I think that's the case. Yeah, so I can hear you actually. You can talk, but I think that's the case. So I would ask him to take a photo from your test and mail it to you. Is that good? Okay. Okay, thank you. Okay, stay safe. Goodbye.